Good evening, everyone, and welcome to today's session on IoT. Today, the session again will be taken by Vaibhav Jindal. I have already introduced him to you yesterday. So, he'll be taking your class today and giving you some insights about IoT today. Good evening, Vaibhav.
Good evening, ma'am. Is my screen visible and am I audible?
Yes, Vaibhav, it is visible.
Okay, ma'am. Okay. So let us start with today's session. Uh, so yesterday we discussed the very brief introduction about IoT. We talked about some of IoT's examples, the need for IoT and what is its true potential. We also discussed about cloud computing and fog computing as well. So in today's lecture, what we will be discussing about is three things. The first thing that we will be talking about is the two main devices that are commonly used in most of the IoT projects and IoT applications, which are Arduino and the Raspberry Pi. The second thing we will be talking about today is making up a career in IoT. Like what are the job trends, what are the job roles that IoT professionals generally get, and what are the market trends and salary packages and skills required for that. And in the end, I'll be demonstrating two of my personal projects that I have made in the last couple of months under the CBREC team. So let us start with the first thing, that is integrated circuit boards, Arduino and the Raspberry Pi. So these are the two most common integrated circuit boards. What do I mean by integrated circuit boards are these contain some pins and microcontrollers, and you can easily make your program into these and connect various kinds of sensors to these devices. So let me talk about these a little bit and then we'll move forward. So the Arduino is a very simple integrated circuit board. It has some pins, some digital pins, some analog pins, power pins, and it has a microcontroller which is Atmega 328 for the Arduino Uno model. It is a very less configuration CPU or less configuration microcontroller, so you can perform only very simple arithmetic and logical operations on it. It is a very cheap device. You could easily get it for like 350 or 400 rupees in the market. And if we talk about the Raspberry, this is kind of a newer device in comparison to the Arduino. This is actually a credit card size computer in itself. This device right here is as powerful as our modern day computers or our laptops that we are using today to attend this meeting. The Raspberry again has some features. We'll be talking about both of features of both of these devices as we move forward. So let us talk about the specifications of each of these. So as I talked about, the Arduino Uno, which is the most common Arduino board available in the market, has Atmega 328 microcontroller with it. This microcontroller is like very less configured, so you could only perform very simple logical and relational logical and algebraic operations on it. The RAM size on the Arduino is just 2 kilobytes and the CPU architecture is 8-bit. What this means is that you can only store a number as big as 255 in a single variable on the Arduino. Since this is a very less configured microcontroller or CPU, so there is no provision of installing an operating system on the Arduino Uno. The processing speed is also quite low, and since this is a very simple device, the power consumption is also very low. If we talk about Raspberry, on the other hand, Raspberry has a Broadcom BCM chip as its CPU. Now, this chip is as powerful as the chips that are present on our laptop systems, like the Intel chips or the AMD chips that we have on our laptops. The minimum amount of RAM that comes with the Raspberry 3B plus model is 1 GB. CPU architecture is 64-bit, which is same as the architecture that is present on a computer systems. Now this is actually a computer, so you can obviously install different kind of operating systems on it. Like two of the most common operating systems that are supported by the Raspberry Foundation as well are Noobs and the Raspbian OS. The processing speed is also quite high, and there is hardly any difference if you use it and any other PC or any other computer use it, you will hardly find any difference. The power consumption is also quite higher than the Arduino. However, it is still very less as if we compare it to the our computers and laptops, and it can also run on DC power supply. Like you don't need an AC power supply for that. Moving on to their modes of operation, the Arduino board is a very simple board, so it doesn't support any audio ports or any GUI. Like you can't play music using the Arduino boards, or you can't view the files in a graphical user interface, much like we have in our Windows systems. And the code that is written for the Arduino programs is written in a specific Arduino ID that is provided by the Arduino founders, Arduino organization. This is a very simple machine, so it is best at using programs that are performed repetitively and are less CPU intensive. Whereas if we talk about the Raspberry, now Raspberry is a computer in itself, so it supports audio and it supports GUI, that is graphical user interfaces. So you could actually play music on it. You could actually see the files and everything that is present on the Raspberry. There are a large number of operating systems that can be used, that can be installed on the Raspberry, and even you could use various programming languages to write codes for the programs on Raspberry. Like you could use Python, you could use C, C++, anything. And since this is a computer, so there is hardly anything that it cannot do that a modern day computer can do. So there are a large number of uses and use cases that you could imagine. Talking about the boards that are available for both. So for Arduino, the most common board that is available in the market is the Arduino Uno. This is again, as I talked about, is very cheap, like 350 or 400 rupees. A bigger version of this is the Arduino Mega, and then we also have some specific use cases boards like the Arduino Lilypad and the Arduino Bluetooth. For the Raspberry, its generation begin from 1 and the latest one is 4. So we have models like the Raspberry 1A Plus, the Raspberry 2B, the Raspberry 0WH, the Raspberry 3B Plus, and the most latest one is the Raspberry Pi 4. So these are some of the features that are introduced on the Raspberry 4. So let me talk a little bit about these. So the first thing is this 40-pin general purpose input output header. Now this is one of the most interesting and one of the most useful things that is present on the Raspberry, as these pins are used to connect various devices, electronic components and sensors to the Raspberry. We'll talk about these pins in the further slides, and we'll look at the pin diagram as well. Talking about the CPU, we have an upgraded Broadcom chip that is present on the Raspberry 4. The RAM actually, the Raspberry 4 comes in 3 different variants of RAM. You could buy a 2 GB model, a 4 GB model, or an 8 GB model. The 4 GB one cost at about 4,500 rupees, and the 8 GB one cost at about 8,000 rupees. Then we have an Ethernet port. You could just simply plug in an Ethernet cable to connect the Raspberry to a network or to the internet. We have 4 USB ports with it. 2 are of USB 3.2 and 2 are USB 2.2. Then we have a stereo audio jack with it. We have an audio port. We can use this to connect our speakers or connect our headphones to it if we are listening to music or if we want to play music. We have a CSI port. The CSI port is actually used to install the Pi camera module, which is another thing that is very commonly used in projects that are based on the Raspberry whenever a camera is needed. Then we have two micro HDMI ports. The HDMI ports are generally used to connect video aids like connect monitors or display screens. And one interesting feature that we have got with the Raspberry 4 is these micro HDMI ports supports up to 4K videos. So you could imagine that this machine right here can play 4K videos without any lag. So how much powerful can this small box can be? And then we have a USB-C type port. So this USB-C type port is actually only used for giving power to our Raspberry system. So you could simply use your mobile phone's charger, plug in the wire if it is a C type, and it will power up the Raspberry. Then we have some display ports, and on the bottom of it, there is a micro SD card slot. Now this Raspberry doesn't have a hard disk mounted on it, so so the storage that it does, the storage and the installation of operating system and everything, it is done using a micro SD card. Now the official Raspberry OSs support FAT16 and FAT32 systems, so it is better to use a 16 GB or a 32 GB SD card with it. And then we have Bluetooth and Wi-Fi chips enabled in it, so you could directly connect to Bluetooth networks or directly connect to the Wi-Fi network. Moving on, so let me finish the discussion on Arduino. The Arduino is actually fundamentally a C++ environment. What that means is the code that we write for Arduino programs is generally in a language which is very synthetically similar to C or C++ code. So since the point of a discussion in this course is built on the foundations that we learned on Python and use those on IoT. So we'll be skipping over Arduino, but I have attached two tutorial links with on this slide, and I'll be sharing these slides after today's lecture. So if anyone is interested, they can go to any of these. These are the official tutorials that are available on the Arduino website, and this is a YouTube playlist that I personally used when I was learning about Arduino programming. So we'll be talking about the Raspberry now. So we've talked about its specifications, but why was the Raspberry introduced, or what was the motive behind the introduction of Raspberry? I want you all to watch this 2-minute video that has been put up by the Raspberry Foundation on their YouTube channel. Let me play this.
This is a Raspberry Pi. It's a credit card-sized computer that costs around £25, designed to teach young people to program, and is capable of doing all kinds of wonderful things. Back in the 80s, kids had to learn how to code computers to use them, and as a result, these kids grew up with an inbuilt understanding of how computers work. Now, we need more programmers than ever before. So to deal with this problem, some clever people came up with the Raspberry Pi to reignite the spark. It runs Linux, a free operating system from an SD card, just like the one in your digital camera, and it's powered by a USB phone charger. You just plug in a mouse and a keyboard, connect it to a TV or monitor, and you're ready to go. In schools, not only is Raspberry Pi a great way to learn programming skills as part of ICT, there are also dozens of cross-curricular applications, like science and music. And all over the world, people are experimenting with Raspberry Pis and attending Raspberry Jam events, where people of all ages are learning what can be done with a Raspberry Pi. Since the first Raspberry Pi was shipped, we've seen examples of people using the Pi in a variety of amazing and interesting projects, taking advantage of its size, portability, cost, programmability, and connectability. So whether you want to learn to make games, build robots, or even teach about a parachute, with Raspberry Pi, the sky's the limit.
Okay, so this was the video about the introduction of Raspberry by the Raspberry Foundation. So I hope this video made it clear why the Raspberry was introduced. The problem was that we were seeing that every kid today was growing up in an environment where they had access to computers and access to these technologies at a very early age. And what was happening was with the technological revolution, there was a need of many large number of programmers in today's world. And the Raspberry Foundation people wanted that not only the kids learn how to use the computer, but they also learn how to program it, how to be more innovative and creative using these computers. So that's why they introduced this Raspberry. And this can have a large number of use cases. Like if you just Google Raspberry projects, or if you just go to YouTube and write Raspberry projects, you'll see a ton of projects that are done using Raspberry. So that is one thing. And now let us move back to the discussion we were having regarding Raspberry. So most of the Raspberry models that have been introduced till date can be generalized with this diagram. So we have this 40-pin general purpose input output header that we'll be talking about in for the slides. We have USB ports. You could easily plug in a mouse or a keyboard that supports a USB port and easily use that with your Raspberry. There is this Ethernet port which you could use to get access to the Wi-Fi or get access to the internet. And the latest models even support Wi-Fi chips, so you could directly connect to the Wi-Fi using that to the internet using Wi-Fi also. And then we have audio jacks for listening to music or for playing music. We have camera modules for connecting camera devices, and and we also have an HDMI port that we can use to connect displays on monitors to our Raspberry. And we have a micro USB cable that we use to power up the Raspberry. And the last thing that we have is a micro SD card, which acts as the hard disk for the Raspberry. So you could install the operating system and store all your files and programs in the SD card itself. So we can see that actually if we just connect an monitor or a television with the using the HDMI ports, and we connect say a keyboard and a mouse using the USB ports, this acts as a CPU and we have our whole new computer system ready with us. Moving on, a few one-line description of most common ports. So we have the USB ports again, which can be used to connect to a wide variety of components like a mouse, a keyboard. Then we have HDMI ports. HDMI port is used to get connected to a display to a monitor. The audio jack is used to connect to standard headphones and speakers. Moving on, we have a micro USB port. The micro USB port is only used for power, is only used to power a Raspberry. It should not be used for any other purposes. And you could simply use your mobile phone's charger to power up the Raspberry as well. Then we have the GPIO pins, the general purpose input output pin, that 40-pin header we saw and we'll be talking about in the next slide. And in the end, we have the SD card slot. Now the SD card slot, the Raspberry uses in the same way a full-size computer uses a hard drive. So you install the operating system, you add all the files, you access them, you modify them and everything. Okay, so the pin diagram. This is actually one of the most important things that we must take into account and we must learn about when working with the Raspberry. So you could see these pins. There are 20 pins in each row, and so we have a 40-pin header, which is projected like this in this diagram. So you could see that there are some 5 or 6 types of pins that are present in it. The most common ones are the GPIO pins, general purpose input output pins. Like you have all these orange pins, which are GPIO pins. what these GPIO pins are nothing but digital pins. So you could set them in you could use them in two states, a high state and a low state. What high state signifies is that power is being provided to this port. So you have a +5 or +3.3 volts power at this point. And a low state signifies that there is no power. So this acts as a ground. And the next thing is ground. We have six or seven. We have seven. We have 8 ground pins on the Raspberry at different locations. And next we have 4 power pins. First one 17, second and fourth. There are two types of power supplies that Raspberry can use, which are 5 volts and 3.3 volts. 2 pins 27 and 28 are reserved pins. So these are reserved for some internal functioning of the Raspberry, and nothing should be connected on these. And if we look at this diagram, we can see that some of the GPIO pins are actually multifunctional. Like you'll see two sets of SPI pins. We have SPIO and we have SPI1. These SPI is actually serial peripheral interface. This is a method of communication of a method of serial communication of data between devices, and these GPIO pins can actually not be, can actually be used in two types. Like you could use them simply as digital input output pins, or you could use them for serial communication. Same goes for the pins 3 and 5, which are I2C pins. So I2C is another communication protocol, just like the SPI for serial communication. I2C is actually useful when you have to determine the number of devices that are connected to your system, and you have to monitor which one is working and which one is not. And we also have two UART technology pins. UART is actually a hardware communication technology. Like SPI and I2C could be used as digital outputs as well, but the architecture behind the UART pins is a little different, so you can't use them as normal GPIO pins. Another thing that I wanted to uh, can everyone mute themselves? Okay, fine. So another thing that I wanted to tell about the GPIO pins is that not only these can take up two states, but these also are used in two states. Like you have an input state and an output state, and you can't use one pin at the same time in both input and output states. What happens in the output state is that you could assign a state to it, a power to it. Like you could assign, if you have said, say, the GPIO 17 as an output pin, you could assign it as a high or as a low. If it is assigned as high, that means power is being supplied to it. And if it is assigned as low, that means power has been taken out of it and it is now as same as a ground pin. And similarly, if I set the same pin as an input pin, then what happens is I can't manipulate its state as high or low by myself. I must connect some device that will actually be manipulating the power or the state of this pin as 1 or 0. As since this is a digital pin, it can take two states, high, low, or 1, 0. So that thing would be manipulating it. And since I've set this as an input pin, I can read its status. I can read whether this is currently at a state of high or at a state of low. Another thing that we can see is you could see that there is two types of numbering that is done on this pin diagram. One is the right one, 1, 3, 5, 7, 9 till 39, and on the right we have 2, 4, 6 till 40. This is known as board numbering. This is common for all the Raspberry systems that are available out there. And the second thing is we have GPIO 2, GPIO 3, GPIO 4, GPIO 18. So these numbers are referred to as BCM numbers or Broadcom numbers, the chip that is installed on the Raspberry. So these can be different for different models of the Raspberry. So while working with the code, while implementing writing programs for the Raspberry, we must take into account that we use either one of the mode, either we use the board mode or either we use the BCM mode, and we stick to it. We should not be changing it at different intervals, as it can lead us to using some pin which we didn't mean to use, and it can actually even destroy our Raspberry system. Okay, so a little bit of hands-on. Let us look at some of the code that we can use to actually use this GPIO pins. So this import rpi.gpio as GPIO. Now you all must have basic understanding of Python and Python modules. So this module rpi.gpio is actually a Python package that is used for getting uh, for manipulating the data, manipulating the states or reading the states or assigning states to these GPIO pins, basically manipulating with these GPIO pins. If this is not present on your systems, you could simply do pip install rpi.gpio and then you could import it. Then then this rpi.gpio actually provides us with certain functions. Like we have set mode, setup, input, and output. So let me talk about each of these. The first is set mode. In the previous slide, I talked about that there are two types of numbering that is done. We have 13579 and we have this 23417. The 13579 was board numbering and the 234 was BCM numbering. So while working with the code, we must ensure that we specify which mode will we be using. If I specify the BCM mode, I must make sure that whenever I'm writing a pin number, I'm writing the pin numbers that are associated in the that are given in the BCM mode only, BCM numbering only. And if I'm doing it for the board, I must give the pin numbers according to the board numbering only. The next function is setup. So before I start using any pin or before I start reading the status of any pin or assigning a state to any pin, I must set up that pin that I'll be using this pin in this mode. So this takes in two arguments. The first argument is the pin number and the second argument is whether I'll be setting it in output, whether I'll be using it in output mode or the input mode. And the next thing is if I've set up a pin as an input mode, so I could read its status whether it is currently in a high state or a low state by simply calling the input function and passing in the pin number. This will return us a 0 or 1. 0 signifies the low state and 1 signifies high state. And similarly, if I've set up a pin as an output pin, that means I'll be assigning the states to it. So I could simply do that using the output function, which again takes two parameters. First is the pin number and the second is the state, lower, high, or 0 or 1, which I'll be assigning to the current pin. So let us have a little demonstration now. Now I know that many of us might not have a direct access to Raspberry machines at their home, so I found out this online ID that you could use to write very simple Raspberry programs. So let me just run this program and then I'll be talking about what it is doing step by step. So I could just click on this run and look here. Okay, so the code has run. What happened is this is the same 40 pin architecture or 40 pin general purpose input output header, and all the green ones are actually the GPIO pins you could see. So now let us talk about what happened in the code. So the first thing that we are doing is importing the same Python package that we talked about, rpi.gpio, and we are also importing a time library. Now, you must have learnt about the time library in the Python course, and the time library basically provides us a function which is sleep, and the sleep function can be used to delay the execution of further code by the amount of seconds that we specify in its argument. So we'll be using it for that. Now we set up the pin 3 as output pin. Now, one thing that you might notice that I have not set up any mode on this. I have not set up it as a BCM mode or board mode, because by default the code is run in board mode on this ID. I have previously checked it, so I have not done that. I'll show this with BCM as well in a couple of seconds. So once I've set up the pin number 3, this is in board mode. So you could see the 1357. This is board mode, and the pin number 3 is this one. And I set this as output. That means I'll be assigning states to it. I'll be assigning lower high states to it. So the next thing is we have a loop that runs 5 times. And what we are doing in this loop is first we are using the output function on the same pin and assigning it a state of high. So what happens is when we assign it a state of high, electricity starts flowing through it and the LED lights up. Now we introduce a time delay of 1 second. So for 1 second, the LED keeps on lighting up, is an on state. Then we again call the output function again on the same pin, but this time what we are doing is we are supplying a low output. We are setting it in the low state. That is, we are cutting down the electricity connection. The pin now acts as ground, and so the LED stops. The LED turns off. We again introduce a time delay of 1 second. That is, the LED remains off for a second. Now, what happens is the second iteration of this loop continues. You might be knowing that for I in range 5 means that I would be taking values of 0, 1, 2, 3, and 4. So once the I value is 0, it runs for it runs one time, and this actually code blinks the LED once. And then again the iteration occurs, and again the LED blinks. This iteration occurs 5 times, so the LED blinks 5 times. Now, if I have to talk about BCM mode, now you could actually see that we have a BCM2 here. That means this pin right here is BCM2 and this is BCM3. So let us see what happens if we set mode on this as BCM. By our current understanding, what must happen is the pin number 3 of BCM should now blink 5 times, and the pin number 3 of BCM is this one, the 5th pin by the board numbering and the 3rd pin by BCM numbering. Let me run this code again. Okay, so we can see that now this one, the 5th board numbering or the 3rd BCM pin, starts blinking 5 times. So this was a very simple code that you could actually use on the Raspberry. I just wanted to demonstrate how you could code and use your GPIO pins for any program. I have also given you an assignment that you will be getting at about 6 p.m. I'll talk about the assignment a little bit. So what you have to do in that assignment is you can see that we have all these green pins as GPIO pins. So what I want you to do is loop over each pin, 3, 5, 7, 8, 10, 12, loop over each pin. And if the pin number is odd, we are talking about board mode only. So the 3, 5, 7 and 8, 12, 10, 12, this numbering. If the pin number is odd, I want you to blink that once. These white boxes are actually LEDs. So when the code runs, these will blink as LEDs only. So what I want is these LEDs should blink once if the board numbering is odd, and if the board numbering is even, that is the above row, top row, then the LED should blink twice. I hope this was clear about the assignment. I've also noted down some hints and ways you could implement this, but I hope it will be very clear to you. You just have to set these pins as outputs and write down a function that could actually, depending on the pin number, blink it once or twice. Okay, so this was about the code. Now let us move back to our presentation. Yes, so this was one example that we discussed yesterday. If some of you might remember, we talked about a smart farming system where we could automate the process of watering our garden or watering our plants. So this is a smart irrigation system. And now that we know of these boards, the Arduino board and the Raspberry board, let us see how we can actually implement these using these boards. So we have this field where we have different tracks which we want to water or which we want to irrigate. So on each track we have installed a sensor, which is the soil moisture sensor, which returns us the moisture content of soil. And we are using an Arduino along with each of these sensors. So the Arduino extracts the information of the soil moisture from these sensors, and each of these Arduinos over Wi-Fi is transporting that data, communicating that data to our Raspberry model, to our Raspberry device. Now, the Raspberry is actually acting as the main hub in this entire system. What the Raspberry does is it obtains the input from different Arduino devices. It processes it, it uniquely identifies this input is of which Arduino, and it sees whether this track has sufficient amount of moisture content already or not. Like we can see that the second track has a less amount of soil moisture. So when the Arduino when the Raspberry would get a signal and would get the data that the Arduino second has less soil moisture content, it would output two signals. The first signal would be going through this relay. Now this relay is actually acting just as a switch, as an on-off switch. When a high signal is received by this relay from the Raspberry, it will start this water pump and water will start flowing in this water pipe. And the second signal that this Raspberry would be sending would be to these gates that we have installed over each track. So as soon as the Raspberry detects that the second track needs some water, so it will send two signals, one to turn on the water pump and the second to turn on this gate, and the track gets irrigated or track gets watered. So this was how you could actually implement a smart irrigation system with the help of your Raspberry and other devices. Okay, talking about the future scope, now we've talked almost everything about IoT. Let us talk about the three things that are currently still a big concern for the field of IoT and still is a very huge field of research in IoT. So the first thing is energy. We still need energy efficient algorithms that are designed for a system so that we do not run out of energy and we are able to run all these programs, all these devices for a longer period of time. Second is security. Yesterday we talked about that there are around 23 billion devices that were connected by 2018, and by 2025 we are projecting that number to go up by 80 billion. So we could see that when there is so much of data transfer happening every second, every device is sending data to some device, proper security channels, proper security protocols are used for the communication of this data, and there is no manipulation of data in between the communication. So this is again a very and this is again something that is very much researched in the field of IoT. And the third is real time. Now we talked yesterday about how we were able to reduce the latency issues that we were getting in the cloud computing by using fog computing technology. But still, there is some gap between the machine real time and the actual real time, and researchers are looking for things that could actually make the processes more real time than they still are. Okay, so this concludes the first thing that we were going to discuss today. Now moving on the second thing, that is career and IoT. The agenda of this discussion would be to give you an overview about how you could go about making up a career in IoT, how you could end up being an IoT professional, talk about the market trends and projections, talk about salary trends, the companies that hire for IoT professionals, the roles that are available in today's time for IT professionals, and the roles that are projected to be available in upcoming years for IT professionals, and also talk a little bit about the skills required for IT, skills that are generally looked by companies and IT professionals. Talking about the overview, so we have seen that there is a large growth in the number of IoT devices and the large growth in this IoT sector itself in the last few years, especially after the growth in the growth in the technologies like AI. So we have seen that the IoT is actually a very growing field, and even the governments and private corporations are laying emphasis on establishing smart cities. Like smart cities are being talked about in India. So we can see that there is actually a huge potential if we try to make up our career in IT, if we try to be an IT professional. Talking about the salary trends, the median salary for an IT professional across all skill sets. Now, this includes a fresher as well as someone who has say more than 10 years of experience. The median salary ranges at about 15 LP, and this data is of 2018. So by 2019, it was projected that this number would go up at about 17.5 LPA, and we can see that actually IoT is very new entrant in corporate sector. Like there are very few companies that are actually at a massive scale using IoT today, and they are still in the experimental phases. So it is actually a very tough job to find a good IoT professional in today's time. So they are offering such salaries, such high packages to them. Talking about IoT versus other domains. So if we have a look at the number of a percentage of number of professionals that are working in the corporate sector and in each subcategory, so we can see that there is a very less percentage of people that are working as IoT professionals in the corporate compared to other fields like the IT, the business research and R&D, which are actually earning less than 6 LPA package. And as we move forward to the next levels of salary packages, we can see that the number of IIT professionals, the percentage of IIT professionals that are working today in the corporate sector and are earning these salaries is quite higher than the other fields like the common fields like IT, business research and R&D. Talking about by experience, so we can say that most of the freshers actually fall under the category of 6 LP only. Since there is a huge shortage of good IT professionals, most companies hire professionals that, for a very generalized role. Like you won't be seeing a job description that says IT professional only. You will be seeing job descriptions where they'll be mentioning some skill sets, and one of these would be IoT. But as your experience grows, you can see that with each level, uh, the salary hike for you is almost at about 50%. So starting from 6 LPA, you could jump at about 9 LPA, then at about 15 LPA, and with 10 to 12 years of experience or even more, you could be earning more than 30 lakhs per annum. So talking about some of the companies that hire IT professionals, again, these companies hire IT professionals mainly in very generalized role. You won't see a company stating that they need a IT professional as of now, but this is something that we are looking forward to in the upcoming years. So the few companies that I've listed are Amazon, Google, Verizon, SAP, Qualcomm. Qualcomm, if you know, we have Qualcomm processors in our mobile devices. Then we have Cisco, the WebEx platform that we are using today for our meeting. We have Bosch, we have Accenture, and we have companies like IBM also. Moving on, the current roles for IIT professional. So as I talked about that, currently the scenario is such that no company is willing to hire an IoT specialist and most of the companies are actually willing to hire people for a more generalized role with some knowledge about IoT. Like the job description includes IoT, but not as the main thing that they want in that person, main thing that they want in their recruit. So some of the common roles that include an IoT skill set as well in today's market are UI UX designers. Then we have network engineers, backend developers, technical consultants, M2M engineers, and customer support. So these are the few roles that companies generally hire in today's time. But they also are looking for people which have an IoT background or have an IoT understanding in these roles. Talking about the emerging roles, so we can see that although now companies are looking for more generalized roles, but with time we can see that with this IoT sector booming in the corporate, we can see expect that we'll be getting specialist roles, like you will be getting roles as solutions architect, as product managers, PM roles. We'll be getting industrial data scientists, the industrial engineers, full stack developers, and even robot coordinators. So these would be highly IoT specific roles that we are predicting that we'll be getting in the upcoming few years. And lastly, talking about the skills that are generally looked in an IoT professional. So these are some of the things that most companies prefer in their recruit, that they have a sound knowledge of embedded systems like these hardware we talked about, the Arduino, the Raspberry, different sensors, connecting them, the protocols that are used for their communication of data. Then we have networking and network security, how the data is being transferred, is it secure, is it not? Then we have UI UX design. We have this IoT project, we have this IoT application, but can any user use it? Are we providing a good enough experience for the user? Then some basic things like programming and analytics. Now, programming and analytics are some of the things that almost all jobs today want in the recruits. If it is a coding job, if it is, especially if it is a coding role. And for IT professionals, the companies also look for cloud computing and edge computing technologies. Like the person must have some knowledge about these technologies. And then is the communication protocols, again a part of the network security. And we have soft skills. Definitely any company would want a more confident, a more interactive person who could do public speaking and other things. So soft skills are equally important along with these technical skills. So with this, we conclude the second thing that we were to discuss today. We've talked about the integrated circuit boards, and we have talked about making up a career in IoT as an IoT professional. Now, the last thing that we'll be talking about today is the projects that I have made. I'll be showing you two of my projects that I have made in the last couple of months under CBREC. So let me start with the first project. The first project is a data acquisition platform, IoT to cloud. I'll just open up this link. So this is our CBREC's website. You could just navigate to projects and you'll be able to see all the projects. So this is one of the projects that I made, a data acquisition platform, IoT to cloud. The main aim of this project was that we are able to send data from our IoT device to the cloud services. The protocol that we used was MQTT, and we used a Raspberry for it, and the cloud services that we used were GCP. For testing it out, we used two sensors. One was IR sensor. IR sensor is basically used for object detection, and the other was MQ135 gas sensor. And this actually gives out the gas percentages in ppm of different gases. Like this one gave us the values of carbon dioxide, carbon monoxide, and ammonia. I'll just show you these. So you could navigate at the bottom and you can see the pictures. Like we have this Raspberry, we have this MQ135 sensor that is connected to the Raspberry, and we were able to send this data. I'll talk about all the steps through the slides only. This was just something I wanted to show. And yes, there is this external link for project at the bottom. You could just click it and it will navigate you to the GitHub account where all the code for this project is available. We'll be talking about this code as well. So let me continue with my presentation. So talking about the directory structure, I'll be showing you this. So if you actually look at the GitHub, the directory structure looks somewhat like this. We have two files in the main directory. We have this gcp json.py. This is a Python script that does the main task of sending the data from our local server to the cloud server, from a local machine to the cloud server. Then we have a README file. The README file actually have all the instructions on how to set up this project and how to use it if you want to use it for your own users. And then we have these two folders. We have a sample cloud output and census data. So the folder sample cloud output has two images, the irsensor.png and mq135sensor.png. Each of these pictures actually include the output that we received on a cloud service on our GCP account. And the census data actually consists of the scripts that we use to grab out the data from these sensors. Like the irsensor.py contains the code that was used to grab out the data from the IR sensor, and the MQ135 gas sensor.py contains the code that was used to grab the values of different gases from that gas sensor. Let me show this to you on the GitHub as well. So you can see we have a README file. The GitHub is actually a site. If you don't know, GitHub is actually used to maintain your project repositories. You can work remotely with your teams using GitHub, and this is something that is very useful if anyone wants to take up a coding job or anyone wants to take up a development job. In fact, this is one of the things that you definitely should know. So I was talking about, so this is the README file. What GitHub does is it renders the README file on the home page itself. So you could see we have all the instructions and everything here only. And the second thing was the GCP json.py file. This actually has the code for sending the data from the local device to the cloud. And then we have the sensors data folder. As we saw, we have two Python scripts in this for grabbing data from the IR sensor and for grabbing data from the gas sensor. And we also have the sample cloud output folder, which has these two images of the data we received from the cloud on the cloud. So moving on. Okay, so we can actually divide the entire project into three phases. Like if I have to use this project, I'll be doing it in three phases. The first phase is definitely reading sensor data. Now, if I don't have my data from the sensor locally as well, how would I be sending it on a cloud service, right? So for that, the steps that you need to follow is you simply add the Python script that is reading data from the sensor in the sensors data folder. We saw that there are two files, IR sensor and MQ135 gas sensor. You could use them as examples. And then you have to modify the get payload function that is present in the GCP JSON file. Actually, whatever is returned by this get payload function is actually sent on the cloud server. So you must update it, you must modify it so that the correct thing is being returned from this function, and only that would be getting transferred to your cloud service. One thing to note is the get payload function must return a Python object or a Python dictionary. You must have studied about Python dictionaries in the course. Python dictionaries are nothing but key value pairs. So that should be one thing. Let me show you this. So if I open up the GCP JSON.py file and scroll down a little bit, I hope you are able to see this. We have this function get payload, which we have talked about, and this is returning this thing if it is a gas sensor, if we were using for gas sensor, and this thing for the IR sensor. This is actually calling a function which might further be returning some value. So let us look at these. Let us start with the IR sensor only. So if I click on this, we can see that the function is defined in the sensors data folder in the IR sensor file. So let me click on this, and you could see this code. Like, this is the most generic code you could see, and this is something that we've seen only a couple of slides back, right? We coded this. So you can see that on the first line we have the import command that we'll be using this package, and then we set the GPIO in board mode, and then we are using the pin number 3 as an input pin. Now, this is one difference that we were not able to see on the ID, because this pin would be getting data from the IR sensor. So we only need to read the data from this pin, and we don't need to output anything or assign any state to it, high or low. So that is why we are using it in the in state. And then we have this get IR value function, which first of all reads the input value from which first of all reads the status of the pin number 3 in the board mode, and once it has read that, it returns a Python dictionary which has a single key value pairing. Key is IR value, and the value is whatever the status is returned from the pin number 3. Now this will obviously be 0 or 1, since this GPIO pins are actually digital pins, so they only have two states, 0 and 1. So the value would be 0 and 1, and what 0 signifies in this case is that there is no object present. This IR sensor is actually an object detection sensor, so this 0 signifies that there is no object present in front of the IR sensor, and if we are getting a value of 1, it will signify that there is some object that is present in front of the IR sensor. And if I come back and if I show you this MQ percentage, now this function is defined in the MQ135 gas sensor .py file under the sensors data folder. So if I just navigate to it, you could see this. Now this file contains a lot of code that you might not be very familiar with, and I would not want to intimidate you with all this code, but let me break this down in very simple steps. So what we are doing in this function is we are initiating a Python dictionary, an empty Python dictionary, and naming it as val. And then we are reading the data from the pin that was connected to our MQ135 gas sensor, and then we have these specific functions that are available with the library we were using for this gas detection, and we can see that we are assigning three keys, and three key value pairings. So the first one we are doing is the gas CO2, and the gas CO2 will actually have the value of actually have the concentration of the carbon dioxide gas in ppms. The second key would be gas CO. So the gas CO would actually be having the concentration of the carbon monoxide gas, and similarly we have gas NH4 which would be having the concentration of the ammonia gas. Now, once our Python dictionary is ready, we have all these three key value pairs. We return it, and this gets returned from a get payload function and will be uploaded to the cloud server. So this was about reading sensor data. Now the second thing is cloud environment setup. We are done with the local system setup. What about the cloud server? So what we used was the GCP platform, the Google Cloud Platform, and these things I'll talk about them, but these might seem a little over the head right now. So what I've done is I've integrated a link right here, right? If you click on it, you will be taken to a Quick Labs website. Now, what is Quick Labs? I'll talk about it also. So, what Google did was Google came up with this website called quicklabs.com, and on this, Google have actually made some hands-on self-paced labs. Like you have different kinds of labs. Like this one is streaming IoT data to cloud storage, and we have so many different labs that you can actually you can take on the Quick Labs website, and each of these labs actually teach you how to use the Google Cloud platform, and these are hands-on. Like you will be doing everything. You will be coding. You will be seeing how the data is flowing and everything. So if anyone is actually interested in knowing more about these things, they can click on that link and it will take you to this website. This might ask you to sign up. If you are scrolling it, this might ask you to sign up so you can sign in with your Google account. One thing that you might not be able to do is start this lab. You cannot have an hands-on experience, as each of these labs actually cost some credits and these credits are paid. Like I think we have $1 for each credit, so you might not be willing to do that, but you can obviously read everything. We have all these screenshots and everything of what is going on. You can actually understand what is happening on the cloud server, on the cloud system a little better if you give a reading to this Quick Labs lab. So let me talk about this now. So first of all, we make an account on the Google Cloud platform. Next, we create a pub sub topic for a streaming data. So this is how the Google Cloud platform actually works. For streaming data from a local system to the cloud server, we must create this thing, a pub sub topic, a publish topic, and this is actually used to monitor the data that is flowing from our local system to the cloud server. The next thing we do is create a storage bucket. Now, on the Google Cloud, there are actually storage buckets or storage that you can create. Uh, and the storage is actually used to store the data that is coming from the IoT device on the cloud system only. And the fourth step is you start a data flow job. Now the data flow job does what? So the data flow job takes the data that is being monitored by the PubSub topic that is being streamed onto the cloud system, and it saves that data onto the storage bucket that we just created. And since we are streaming this data from an IoT device, so GCP has another feature which is available under the IoT core, and we have to create a registry. Basically, we have to tell the Google Cloud System server that we'll be sending the data from this device, and so the communication is safe and secure. The Google Cloud environment provides us some keys and values, some certificates as well, so that there is no manipulation of data in between, and the communication happens as securely as possible. So transferring data to cloud. Now that we are ready with the local setup, and we are ready with the cloud setup as well. The next thing that we do is transfer this data to cloud. Now for that we require some Python packages to be installed beforehand. So these are like the PyJWT, PAHO, MQTT, cryptography. These are some of the Python packages that you will be needing in order to send the data to the cloud. We also set up some environment variables, and at the final step, we run the GCP JSON.py script, which was present in our main directory. Now, this might seem a little bit confusing, but if you actually break it, you can see that the main thing that we are doing is only this one, Python GCP JSON.py, which is saying that, hey Python, run this Python script, the script named as GCP JSON.py, and all these things that we have after it are actually some command line arguments that we are sending to our that are being used in our GCP JSON script. So we tested it, as I talked about, we tested it using two different sensors. The first one was the IR sensor and the second one was the MQ135 sensor. So this is actually the output we got from the IR sensor on a cloud system. So you can see that each of this is actually a pair, a dictionary kind of object. This is actually JSON JavaScript object notation, which is very similar to a Python dictionary. So we have these three things in it. One is a timestamp, second is the device, and the third is the IR value. This IR value is actually coming from the rsensor.py file in the sensors data folder, and the timestamp and device are actually coming from the GCP JSON.py file only. And similarly for the MQ135, these are the things we got. Again, the timestamp and the device are coming from the GCP JSON.py file only. And these three things, this is the exact same dictionary that we returned from our MQ135 gas sensor.py file, right, in the census data folder. So these are the values that we get here. So this was all about the first project. Now let us move to the second project. So the second project was this electronic preferential voting machine with advanced authentication. The idea behind this project was to digitize the process of Rajya Sabha elections and also provide some kind of authentication with it. Now let me talk a little bit about the motivation behind this. Before that, let me tell you a little bit about the Rajya Sabha. So in India, we have these two houses. We have Lok Sabha, the lower house, and the Rajya Sabha, the upper house. So the Lok Sabha is actually a temporary house. Like after every 5 years, when the Lok Sabha elections happen, it dissolves momentarily, right? But the Rajya Sabha is actually a permanent house. So the Rajya Sabha elections are actually conducted almost every year. The conduct of these elections is a little bit different. This is actually done using a preferential voting kind of system. I'll be talking more about this in the upcoming slide. But this is actually still, to this date, it is actually being done on a ballot paper. And the motivation behind this project was actually some of these things only. There were these news articles like a 2009 report by the Hindustan Times that stated that around 10,000 tons of paper was saved due to the introduction of EVMs in Lok Sabha elections. And why are we not introducing something like that in the Rajya Sabha elections as well, right? Why are we wasting so much paper to this date? And there were other newses as well. Almost every year, almost every 2 years, we were getting these news articles where there was some election fraud going on in the Rajya Sabha elections, like cross voting and everything. So to make sure that all of these malpractices do not occur and to save a paper, save trees, we actually wanted to build the system. So we started out by identifying the problem statement. So as I talked about, the Rajya Sabha elections actually occur every year. However, every 2 years, every second year, almost one third of the party members or one third of the seats get vacant. Rajya Sabha is definitely a permanent house, so it doesn't dissolve completely, but every 2 years, one third of the seats became vacant and elections are conducted on these seats. Now, the election process is actually called as proportional representation through single transferable vote. You can read more about it, or you can just Google or YouTube it, and you'll be knowing more about how does this take place. But this is more of a preferential voting. Like rather than voting for only single candidate, I give up preferences to each of the candidates. Like I have four candidates that are contesting for elections. I assign preferences 1, 2, 3, 4 to each of the candidate. The votes are currently casted manually on a ballot paper, which makes the whole process time consuming, and there are possible chances of human error in counting and vote collection, right? So this was our problem statement that we had taken into account. Uh, Talking about the solution, so this was the solution that we were able to came up with. We divided our whole solution in two steps. So the first one was our authentication system. Now we didn't only wanted that we provide an electronic voting machine and anything can happen with that. We wanted to make sure that there is some amount of authentication as well that is provided along with this voting system. So we divided this entire project into two phases. The first was authentication, where we are using facial recognition using deep learning techniques, and we are also doing biometric recognition, biometric authentication using fingerprints. And the second thing was the voting machine. The voting machine was actually based, the prototype we based is actually on Arduino, and we've used LCD displays for the user interface. Talking about how it works, I'll be explaining in detail about this when we see the demo video, but let me just talk a little bit about this. So the first thing that occurs is the voter enters the voting booth and he goes and he proceeds to the authentication system. The authentication occurs. Authentication is of two types, the facial recognition and the biometric recognition. Once the authentication is successful, the voter now moves on to the voting machine, to the electronic voting machine. Now, the pattern and everything of this voting machine we'll be looking in the video only, and I'll be explaining there only. So, in the second step, basically the voter casts his vote, and finally, once the vote has been casted, the voter returns, and even if he tries to manipulate the system or if he tries to re-vote or something, he will not be able to. Okay, talking about some of the things that we were able to provide to the election officials. These are the election officials can obviously find the list of voters. They can filter out the list of voters, add their fingerprints and images. The process of vote counting and result declaration was also made automatic. Like, you don't have to manually count each and every vote. You can simply run a Python script and it will display the vote, and it will also display the details of each round. Like, the vote counting in this system is done by considering preferences of each at each stage. Like, for the first round, we consider the first preference, and if we are not able to finalize a result out of that, we move on to the second preference and third preference, and so on. So we can actually see all of that through the system. The election officials can also view each of the vote that has been casted on the system. Now, this doesn't mean that he can know which person voted for whom, but they can know that these many number of people and this individual has voted, has given the preferences in this order, but but the officials cannot know which individual was that. So there's the security layer as well. And then there was generating encodings for facial recognition and downloading fingerprints if required. The last thing before we move on to the demo video is some of the other highlights of this system. So, along with the biometric authentication, we talked about using a face recognition module. You could actually read more about these if you click on these links. I'll not be going in much detail about this, but the face recognition module that we used is one of the state-of-the-art modules and have an accuracy of around 99.38% on a very famous data set that is labeled faces in the wild data set. You could read more about all of this by clicking on each of these links, but since this is more about an IoT course, so I'll not be talking about the AI here. And the second thing was voting experience. So we've tried to make the voting experience as smooth as possible and as easy as possible. So even if someone doesn't know how to operate a computer or how to like, even someone has no knowledge about digital devices, they can easily follow the instructions and vote, and there hardly be anything that will make the process difficult. Wherever necessary, we have used lights and LCD displays so that the voter is also getting some feedback from the system at every step, and the whole process like takes less than 3 minutes on an average for the entire process, which includes the authentication as well as casting the vote. So finally, demo time. So let us look at how the system actually works in this video. Okay, so the first thing that happens is the voter comes inside the polling booth and he travels and he goes to the authentication system. So this is the authentication system. You can see that actually there is a camera right over here, which is used for facial recognition. And if you look at this frame, you can see that there is this fingerprint at the bottom, which is used for biometric recognition. Initially, you can see that the red LEDs of camera and fingerprint are running. That means neither of the things have been authenticated or have been verified by the system. The first thing that the user does is place a finger on the fingerprint. Now, if you look closely, the red LED is blinking. That means the authentication failed and the system was not able to find out that whether this is a verified user. But since we are giving two chances to every user, so the user tries again, and you can see that this time the system was able to identify that yes, this is the correct user. This is present in our database, and the green LED turns on. That is fingerprint authentication is successful. Moving on, you could see that the camera light is on now. So that means the facial recognition is being done and this red LED of camera would be blinking. And there goes the facial recognition. So both of these LEDs have turned green. That means authentication has been successful and now the user can move to the voting machine. Okay, so this is our voting machine. As you can see, we have an LCD display that is constantly giving out some feedback to our voters, and then we have this matrix, that this pad which actually has numbers. And how does this matrix works is along each row we have the preferences for the given candidate. Like the first row, these 1 2 3 A are actually the preferences for the candidate 1, and similarly for candidate 2, candidate 3, candidate 4 as well. Talking about preferences, these are column wise. So the first column represents first preference, second column represents second preference, third represents third preference, and fourth represents fourth preference. And then we also have these two buttons with us, reset vote, in case I made a mistake in making out my preferences and I want to reset it. And the second is cast or record my vote. So let us see it in action. I You could actually see that with every press, you are getting this output on the LCD as well. So once everything is done, once all the preferences are given, the LCD displays us all the preferences and asks us whether we want to reset it or cast our vote. Now, since this was a demo video, we wanted to record as many cases as possible. So for the first time, we do the reset, but we press the reset button and we vote again. So this time I give three preferences, and if you actually view these carefully, let me take a few seconds back. Fourth preference, third preference, and second preference. And now I press the cast record button. That means I want to record this vote. Now, some of the rules in the Rajya Sabha elections are that you could only give the preferences, you can only allot the preferences in a sequential order. Like if you are giving out a second preference, you should have already given out first preference to someone and then only you could give out the second preference. But here we saw that we are giving the second, third, and fourth preference, but we have not assigned first preference to anyone. So let us see what will happen after we try to record this vote. So you could see as I press the record vote button, the LCD displays that the vote's preference you have given is incorrect and you need to vote again. So for the final time, I vote again. This time I give out the first preference to the first candidate, second to second, third to third, and fourth to fourth. The LCD again displays me the preferences I allotted. And finally, I have choice of pressing the cast vote and reset button, and I press the cast vote button, and you can see vote has been recorded. The system shuts off, and even if you press any button after that, nothing will happen. So you can see that this video is just of 2 minutes and 30 seconds, and we have covered 3 different aspects in it. So the entire process is actually very less time consuming as well. So this was about the demo video and the second project. Now this is the last slide that I have for today, and then we'll wrap up the session. So these are some of the concerns or questions that we were asked about when we were building the system. So what if there's no electricity, right? We might have polling booths or we might have electricity failures at some places, right? So what can be done about it? Now, our argument was that both of the systems, both of the devices that we used in our authentication as well as voting system are actually Raspa and Arduino only. So these require very less amount of what do I say, less amount of energy, and these can easily be run on a DC current. So there is no requirement of an AC current, and we can easily run these without any electricity as well on batteries. The second was about security. So I I believe that anything that is on a network that is connected to a network or connected to an internet can is somewhat hackable, right? You could extract, you could get information from that in some way or some sorts. But the feature of our project was that neither of the systems were connected to any network. Both were independent. All the storage, processing, and everything was being done locally on the device only. And so this obviously reduces, or this obviously terminates the risk of any hacking or anything. And the last thing that we were asked about was, can someone manipulate the software? Can I give votes to my favorite candidate a large number of times by somewhat doing something? So can I do that? So the thing is, practically no. Because all the possible ways that can be used to do these kinds of things will require what? Will require you to open up the system, will require you to attach a cable or some uh, connect your laptop or some device to it and then transfer that program into that device, right? So even in the first step, when you are opening the program, you are actually damaging it, and we can actually see that the machine has been tampered and there was some malpractice that was trying to be pulled out. So these were all the things that we were majorly concerned with regard to this project, and this was all about today's lecture. These are some of the references that I have personally used in making up these sessions and making up these slides for you. And I'll be sharing all of this content on the Google Classroom only. So you could go through them, you could explore more about it, you could watch the video of these lecture again and again if you want on YouTube, if you have not understood anything. So this was all from my side. Thank you so much, everyone. With this, we conclude this programming with our Python and IoT Perspective course, and I hope you all had a great learning experience. Thank you so much, everyone.
Thank you so much, Vaibhav. It was really a great session. I hope the same is the experience with everyone else. I hope you have enjoyed the session and it was informational to all of you. If you have any doubts, you can ask. And if you have doubts about the PPT used, so Weber will be sharing that in Google Classroom. Anything else than that, you have doubt in that, you can ask right now. And let me give you some information about your certificates. Will take 10 to 12 days for the certificate distribution. You'll get one email regarding the certificates in your Google accounts. Other than that, if you have any doubt, you can ask. See, you will be getting digital certificates, not the printed ones. Digital certificates will be issued to you. For all those who are left with their grades, you will be getting that in a day or two because the number of students were the number was very large in responses. So it is taking time for the evaluation of those. So I hope the lectures were informational to you. And with that, we end the session over here for today. This was the last session for our complete course. So you will be getting your certificates within 10 to 12 days. First assignment was of 10 marks. We'll be sharing one feedback form in your in your WhatsApp group only. Do submit your feedbacks over there. So thank you so much, everyone. With that, we end the session and the course. Thank you.